Welcome to Man Does Tech, where I solve the problems you didn't even know you had.
Start by understanding the precise definition of differentiability at a point. A function is differentiable at x if the derivative limit exists and is finite. Write the limit as h approaches 0 of f, x plus h, minus f, x, divided by h. If that single finite value exists, the function is differentiable at x. Remember that differentiability always implies continuity at the same point. But continuity does not imply differentiability. So next, compute the limit from both sides using the difference quotient. Compute the left-hand limit of f, x plus h, minus f, x, divided by h as h approaches 0 from negative values. Compute the right-hand limit as h approaches 0 from positive values. If the left and right limits match and are finite, conclude the derivative exists at x. Use algebraic simplification, factorization, or the squeeze theorem to evaluate difficult limits accurately and efficiently. Finally, watch for common failure cases when testing differentiability at a point. Inspect corners and cusps where slopes approach different finite values from each side. Check for vertical tangents where the derivative becomes unbounded or infinite. For piecewise functions, compute the derivative limit from each piece at the joining x value and compare. If the left and right derivative limits differ or are unbounded, the function is not differentiable at that point.
Thanks for watching. If you found this helpful, don't forget to like and subscribe.